Today we're going to learn how to factor polynomials by using the strategy called grouping. And it's very important that you pay attention to this part right here that says this strategy only works if you have 4 or more terms, because you're going to have to be able to divide them into 2 groups. And I'm going to show you what I'm talking about right now. If you need to pause the video to write down the problem and the first part of the notes, please do, but I'm gonna go ahead and assume you've paused the video and go on to step 1. Step 1 is to divide the terms into 2 groups. So I'm going to take the first 2 terms and I'm going to put them together in a group. And I'm going to take the second pair of terms and I'm going to put them together in a group. So step 1, I'm just dividing them up into 2 groups. For step 2, I'm going to find the greatest common factor, or of course we call it also the GCF, of each group. So step 2, I'm going to find the greatest common factor, or the GCF, ooh, that was an ugly F, of each group. So I'm going to zoom in right now on the blue group and show you what I mean in case you don't remember what it means to find the greatest common factor. So I'm going to zoom in here. I'm going to look at the first group. And I'm going to pay attention to the coefficients. So I noticed that 25 and 5 are both divisible by 5. I can divide both of them by 5. So the numerical portion of the GCF is going to be a 5 because those are both divisible by 5. Then I noticed that this term has 3 V's. This term has 2 V's. So what can I factor out of both of them? What do they both have in common? Well, I can factor a V to the second out of both of them. So the greatest common factor for the blue group is going to be 5V to the second. Now I am going to zoom in on the green group. And I notice that I've got a 30 and a 6. I'm going to look at the numerical portions first and see what number can be factored out of 30 and 6. And of course, they're both divisible by 6. So the greatest common factor for the numerical portion is 6. And I can't factor anything else out. This one does have a V, but this term does not. And remember, you can only factor out what they have in common. That's why this is called the greatest common factor. So the greatest common factor for this set of terms is simply going to be a 6. So I've now accomplished step 2, which was to find the greatest common factor of each group. So now on to step 3. And in step 3, I need to factor out each GCF. So I'm going to start with the blue group to show you what I mean. So the first thing I need to do is I'm going to write down that greatest common factor, that 5V to the second, and I need to figure out what is going to be left over in these 2 terms after I factor out a 5V to the second. So I'm going to zoom back in on that blue group for a minute. So if I do 25 divided by 5, because that's what it means for me to factor out the 5, that means that I'll have a 5 left over. And then in this portion, if I had 3 V's, and I factored out 2 V's, that means that I'll have 1 V left over after I factor out that 5V to the second. Remember, you don't need to write a 1 there. We kind of know that that 1 is already there. Then, if I look at my second group of terms in this particular group, I have 5, and I'm going to divide it by 5 because that's what it means to factor out the 5. So that means that I will have a plus 1, because that's what 5 divided by 5 is, of course. And I need to put the plus in between there because that's a positive. And then you had 2 v's, and you factored out 2 v's. So that means that you're going to have no v's left over. So you're not going to write anything. So after I factor out that 5v to the second, in that first group of terms, I'll have a 5v plus 1 left over. So I'm going to take that 5v to the first that I had left over, and it's going to go down here with my step 3. So I factored out that 5v to the second, and it's going to be kind of out here by itself out to the side. So I'm going to put what's left over, the 5v plus 1, right there inside of the parentheses. So I took that first blue group, I factored out the greatest common factor, and then this isn't a very mathy term, but the leftover, what's left over after I factored it out, goes right there in parentheses. But the directions here say to factor out each greatest common factor, right? So that means that now I need to factor the 6 out of the green group. So I'm going to zoom in on the green group, and I'm going to factor out that greatest common factor of 6. So if I have 30 divided by 6, because that's what it means to factor out the greatest common factor, 30 divided by 6 is going to be 5. And then I had a v. I didn't factor out any v's. I only factored out a 6, so that means that that v is still there. Then in the second term, I had a 6. I factored out that 6. So then I have 5v plus 1. So after I take the green group and I factor out the greatest common factor, I have 5v plus 1 left over. So after I factored out that greatest common factor, so I need to now write down here, I need to write plus 6 because I need to put the greatest common factor out to the side, and it was a positive 6. So it's out there to the side. I need to fill in the parentheses. And then inside of those parentheses will be, again, for lack of a better term, the leftover. What was left out of that green group after you factored out the 6. So in this case, that would also be a 5v plus 1. So I've done steps 1, 2, and 3 so far. So again, I divided them into 2 groups, and then I found the greatest common factor for each group, and then I factored out each greatest common factor. Notice here how now I have the same thing in each of those parentheses. That is a really good clue to you that you're probably doing this correctly. Grouping is one of the hardest strategies there is, and so it's nice to kind of be reassured that you're probably doing the right thing. So now I'm going to move on to step 4, and I'm going to color code step 4. So you're going to factor out that common binomial. And remember that a binomial has 2 terms, right? That's why it's called bi, like a bicycle. So what's my common binomial? What do I mean by that? Well, it's probably a pretty good clue that I put it in the same color that I put these 2 guys right here. Notice how they're a binomial and that you have them in common. So that's why it's called the common binomial. So what I mean by factoring it out is you're going to take that 5v plus 1, and it's going to become its own. It's kind of like you took each of these 5v's plus 1 and you pulled them out of each little group. So now it's going to become its own binomial together in one. So the common binomial comes out, becomes its own binomial, and then the greatest common factors are left in their own binomial. That is step 5. So what I mean by that is the 5v to the second power becomes one term in a binomial, and then the plus 6 becomes the other term in the binomial. So my final factored answer is 5v plus 1 times 5v to the second plus 6. So that is your fully factored form. I know that this is the toughest part to get down, so I'm hoping you can kind of see like where those are color coded. So again, that common binomial, okay, the one that they had in common, comes out and becomes its own binomial. And then the two greatest common factors, the 5v to the second, goes into its own along with the plus 6. So they are in their own binomial together. And so I just rewrote it all down here for the final fully factored form. As an added step, you can always go back and double check and make sure that your answer is correct. And you can do that by taking the answer that you get at the end, by taking the factored form that you get, and doing our box method that we learned how to do some time ago, where you're going to go back and you're going to multiply these two together. So this becomes 5v plus 1 becomes the length of your box, and the 5v to the second, and then the plus 6 becomes the width of your box. And you can go back and you can multiply them together to make sure that you got the correct answer. So if you do here, we're going to multiply 5v to the second times 5v. So 5v times 5v to the second. 5 times 5 is 25. And then a v and a v to the second is v to the third. Then you do your 5v times 6. So 5v times 6 gives you 30v. Then you could do 1 times 5v to the second, which gives you 5v to the second. And last but not least, you can take 1 times 6. 1 times 6 gives you 6. So look at the 4 terms that you had once you went back and you multiplied these two binomials together. 25v to the third, 30v, 5v to the second, and 6. Notice those are exactly the same 4 terms that you started out with in the original problem. So that kind of illustrates to you what we're doing. It's like we're taking the problem and we're unmultiplying it, getting it back into the 2 terms that you originally multiplied. So you can always use this to go back and check yourself and make sure you did it correctly, because you can go back, take your fully factored form that you got, and you can multiply it back together to see if you get those original 4 terms. Okay, so now I'd like you to try example number 2 with me, but we are going to break it up step by step, so don't worry. I'll be with you the whole way. So the first thing I want you to do is pause the video, and I want you to do step 1, which is to take the terms and divide them into 2 groups. So I'm going to assume that you paused the video, that you got them divided into 2 groups. So I divided these 2 into a group, and then I divided those 2 into a group. So let's move on to step 2, which is to find the greatest common factor for each group. So I want you to pause the video and try to find the greatest common factor for both of those groups now, please. I'm going to assume that you've done that step and that you're just ready to check yourself with me. So I look at the 4 here and I look at the 12 here, and I see that the greatest common factor, the largest thing I can divide both the 4 and the 12 by, is going to be the number 4. So that's part of my greatest common factor. And then I see that this term has 3 v's, This term has 2 v's. So what do they have in common? What can I factor out of both of them? That would be a v to the second. So I found the greatest common factor for my blue group. Now I'm going to find the greatest common factor for my green group. So I've got a 5 here, I've got a 15 here. So the largest number that I can factor out of both of them is a 5. And this one has the variable v, but this one doesn't have any variables. So that means I can't factor any variables out because it's got to be something that they have in common. So the greatest common factor of the green group is just going to be a 5. So step 3, now I want you to pause the video and I want you to try step 3 yourself. I want you to factor the greatest common factor out of each group and then write what's left over when you get finished. So what I mean by that, for example, I want you to take the 4v to the second and I want you to factor it out. And then I want you to write inside of these parentheses what's left over after you factor out that 4v to the second. Then you're going to want to factor out the 5, which means I want you to write in these parentheses what you have left over after you factor the 5 out of that set of terms. So pause the video, try it yourself, please, and return once you're ready to check your work. So I'm going to assume that you have paused the video and you are ready to check because you've tried it yourself. So I'm going to zoom in on the blue group first. So I had a 4. I divided or factored out a 4. So 4 divided by 4 is simply going to give me a 1 in the leftover. Here I had 3 v's. I factored out 2 of them, so that means that I'm going to have 1 v left over. Now, those of you that have been with me for a while know that when you have a 1 in front of that variable, you don't really need it. So I'm going to erase that 1v because we kind of know that if there's no number in front of the variable, we know that there's technically a 1 there. And in math, we like stuff as basic as we can possibly get it. So now I've got a negative 12 and I factored out a 4. So negative 12 divided by 4 will give us a negative 3. And we had 2 v's. We factored out 2 more v's. That means we don't have any v's left over. So that means that all we have in this remainder here is we have a v minus 3 after we factored out the greatest common factor there. So now let's turn our attention to the green greatest common factor group. So I had a negative 5, and I'm going to factor out a positive 5. So a negative 5 divided by a positive 5 is a negative 1. I had a v. I didn't factor the v out, so that means that I'm left with just a v. And again, you guys know that in math, we like to keep things as simple as we possibly can. So I don't want that 1 in front of the v. It's just going to be a plain old negative v. Then I've got a 15, and I'm going to factor out a 5. So 15 divided by 5 means I'm going to have a positive 3. So we've done step 3. We factored out the greatest common factors, and now let's see what's left over. Now, before you continue to the next step, this one's a little tricky. You might have noticed that you have almost the same thing in both of those binomials, but you don't quite have exactly the same thing. You've got exactly the same terms, but they're like flipped. They're opposite of each other. This one's a positive v, while that one's a negative v, and you've got a minus 3 where that one is a positive 3. So when that happens, you can't just factor out the common binomial. They have to be exactly the same, not just almost the same. So this is how we're going to fix that situation. I'm going to turn your attention back to this group right here. And instead of factoring out a positive 5, instead I'm going to factor out a negative 5. So I'm going to erase all this for a moment so that we can see what we're going to get now. So instead of factoring out a positive 5, we're going to factor out a negative 5 instead. So let's see how that changes things. So you've got a negative 5 divided by a negative 5. So now a negative divided by a negative is going to give you a positive 1. You had a v. You still didn't factor out a v. So that means you're left with a positive 1v. And then, of course, remember in math, we like it as simple as it's going to get. So we just need that positive v there left over. We don't need to put the 1 in front of it. So we're just going to leave the v. And then we have a positive 15 divided by a negative 5. So a positive divided by a negative will now give us a minus 3. So now you can see we have the same binomial. It's exactly the same signs and everything. So we're ready to do the next step, which is to factor out that common binomial. So I want you to pause the video, try to factor that out yourself, then restart the video when you are ready to check your work. I'm going to assume that you've already paused the video and you've tried it yourself. So the next step, if you're ready to check, is you're going to factor out that v minus 3, which is going to be in a binomial by itself. And then you're ready for the last step now, I think, which is to take those greatest common factors and put them in a binomial together. So if you haven't already done it, I'm going to give you a second again to pause the video, check, and see whether or not you've done that correctly. So I'm going to give you a minute. Hopefully you've already paused the video and checked, so I'm going to go ahead and keep going. So you've got the 4v to the second, and then the minus 5 go together in a binomial. So I'm just going to rewrite this without the color coding now. Your final fully factored version is v minus 3 and 4v to the second minus 5. And just for funsies, I am going to, actually this isn't just for funsies, I really want you to do this. Go back and check yourself by multiplying to make sure that you did it correctly. So the v minus 3 will become the length of my box. The 4v to the second minus 5 will become the right side of my box. So here if I do v times 4v to the second, that gives me 4v to the third. Here if I do v times negative 5, that gives me a negative 5, negative 5v. Here if I do negative 3 times 4v to the second, that gives me a negative 12v to the second. And last but not least, if I multiply negative 3 times negative 5, that gives me a positive 15. So if I compare each of these 4 terms that I just got by multiplying the answer back together again, you're going to see it matches with all the terms that were in my original problem. So I can rest assured that this is 99.9% probably the correct answer. Okay, one more example for the day, and then we are all done. The first thing I would like you to do is pause the video and go ahead and do the first couple of steps. I want you to divide the 4 terms into 2 separate groups, and then I want you to find the greatest common factor out of each of those groups. So please pause the video, go ahead and try that out. I'm going to assume that you have paused the video and you're ready to check yourself. So I'm going to look at my first group here, the 24p to the third and the 15p to the second. So the largest number that can be factored out of both 24 and 15 is a 3. Here I have 3 p's and I have 2 p's in this term. So that means the greatest thing they have in common is 3p to the second. Then I'm going to look at my second group, and I am going to see that the largest number I can factor out of 56 and 35 is a 7. And I'm going to go ahead and plan ahead here a little bit, because notice how these are both negative and these are both positive. Remember that your goal is that later on you want to have the same binomial once you factor out the greatest common factor. So if these are starting off to be a negative while these are starting off to be a positive, I know I'm probably going to have to go back and make an adjustment. So I'm going to go ahead right from the get-go, and I'm going to factor a -7 out of that pair of terms. So now that we've done the first couple of steps, we divided them into groups, and we found the greatest common factor. I want you to do the next step, which is to factor out the greatest common factor out of each group and write down what's left over. I'm going to assume that you've already done that step, so you've done that 3p to the second. And let's see what we have left over after we factor out that 3p to the second. So we did 24 divided by 3, which is 8. We had 3 p's. We factored out 2 of those p's, which means we have 1 p left over. So we've got 8p left over out of that first term. If we do 15 divided by 3, that's going to leave us with a 5, and it's a +5 because they're +5. I had 2 p's. I factored out 2 of those p's. That means we don't have any p's left over. So that first group will have an 8p plus 5 left over after you factor out the 3p to the second. I factored out the -7. And now let's see what we're going to have left over. So I had a -56, and I factored out a -7. So -56 divided by -7 will be a +8. And then I had a p. I didn't factor out that p, so that p is still remaining. And -35 divided by -7 means I'm going to have a +5 remaining. And so you know that you're probably on the right track, aside from the fact that I'm doing the video with you, of course, because of course you have that common binomial. So now I'd like you to do the last little piece. I want you to factor out, I want you to pause the video first of all, factor out that common binomial, put it in one term or in one binomial by itself, and then put the greatest common factors in another binomial by themselves. I'm going to assume you've paused the video, you've tried this out. So you've got an 8p plus 5 will be one binomial. And then the 3p to the second and the -7 will go together in another binomial. So I'm just going to rewrite it without the color coding. 8p plus 5. And 3p to the second -7. And again, I'm going to go back and just check myself to make sure I did it correctly by multiplying those back together again and making sure I got the right thing. So 8p and 5 is going to be the length of my box. 3p to the second -7 will be the right side of my box. So I'm going to do 8p times 3p to the second. So that's going to leave me with 24p to the third. 8p times a -7 is -56p. 5 times 3p to the second gives me 15p to the second. And 5 times -7 leaves me with a -35. I'm going to glance back up at the original problem. Yep. Each of those 4 individual little terms was what was in my original problem. So I can be assured that I probably did it correctly. And this is going to be my answer right here.